thank you for being here. So today we will present you how to hack your mobile application. So for me, I am Julien Jimenez, and I am a French security expert. So we are coming from France, and for this presentation, I will be the hacker.
Hi everyone, so I'm Amélie. I'm a project manager in Worldline. We are in a mobile security team, but today I will be a project manager. But we will just take the story that I'm working in a bank for a bank, and my bank doesn't have any mobile application. There you say, what? You don't have any mobile application. So we need to have a mobile application, we need to develop a mobile application. And for that, we will see how I will go into how to make a mobile application and how to make a secure mobile application. So the first thing I studied, we need a mobile application, and why is that? Because there are over 6 billion smartphones that are used in the world today. It's a very big number, and more than 86% of population on Earth owns a smartphone. A smartphone meaning application. And when we talk about application, we think everything is secure, we're in the good world, but actually not. More than 75% of applications, very popular applications that everybody knows, they have all been hacked once, and sometimes there were some data leaks from these attacks. And we say, well, it happens on some little applications, but even on financial applications, which you want to think it's very secure, that in fact, less than 50% of financial applications don't have the good level of security in their app. So I wanted to know how to have a secured application, and the first thing that I learned was about the first thing that hackers do to hack an application. They use rooted smartphone. So we talk about root for Android, and we talk about jailbreak for iOS. And actually, what does it mean? It means that you are a super administrator on your smartphone, and it's always the first step that the first thing that a hacker do on his smartphone. But you have to know that your users, the users of your applications, if their own smartphones are rooted or jailbroken, it means that they are vulnerable also to hackers. So it's in the both ways. And so what does it mean to be a super administrator on your smartphone? It allows to access all folders, also all applications folder on your app. Also, you have access to the secure storage of your mobile, or key store or keychain. It also allows to bypass the TLS, see everything that goes in and out the smartphone. Also, everything that is in memory that you will see later. All the logs when you're in debug mode, and all of this you can instrumentate your your smartphone, and that's how hackers can do something on your smartphone. So I wanted to see what it's like to root a smartphone, and the first tool, the tool that is most used to do it is Magisk. So it's very easy to root a smartphone with this tool. And so that's why I developed in my team a root detector, detection of root. So when I launch the application, the device is seen as rooted, and so the application doesn't work. So many applications detect the root to avoid this vulnerability, and also avoid data leaks and attack with tools. So
okay, so
I make a point.
1 point for you, but we will see that it will not be enough to protect a mobile application. I will show you 2 different methods to hack your mobile application. First method we call static analysis, and dynamic analysis. What is the difference? With static analysis, you will have the application which is not running. You will have the application in your hands, in your computer, but it is not running. For dynamic application, dynamic analysis, the application is running, and the attacker will instrument the phone, the application, but directly when the application is running. So we will see this to analyze this code and memory. What is the goal of this analysis? Of course, I will try to bypass the root detection to launch the application on my mobile, which is a malicious mobile, which is a malicious phone, but it is rooted, and I have to run this application. Before doing this, I will explain what security model we are concerning here. In fact, there is two security models, usually speaking, black box and white box. Black box, it's concern server, or here you can see payment terminals or smart card. It means that the attacker has no access to the code, no access to the memory, because there is protections, either network protection like firewall or material protection like a smart card or a terminal. But here we are in a white box model. It means that the phone is in the hand of the attacker, so he can see the application, and he can see also the code, the memory, everything is accessible to him. Now, what is an Android application? In fact, an Android application is a simple zip file renamed with the APK extension. So if we want to see what is inside, we just have to unzip this file, and we will see some resources like images, icons, etc. The signature of the application, and also Android manifest.xml. You know that this file is used to configure some permission, etc. And what's interesting, classes.dex, where is the source code of my application. So here, this is an Android application written in Java. So we will have in the classes.dex the Java source code. Okay, and now how I will understand the code, how I will go into the code. I have two different tools to do this. The first one is APK tool. This one will take the DEX file and transform it into Smally. What is a Smally? Smally, this is this kind of code, which is not very clear, but the advantage of this code is that it is easy to modify it and to go back into DEX. So with this tool, you can go in the two directions, from the DEX to the Smally, and from the Smally to the DEX. And of course, I will modify Smally here before going back to the DEX. Okay, but it's not easy to understand. So I will also have another tool, which is JADX or DEX2JAR. Here there is two tools. And with these tools, I can go from the DEX file, from the DEX file to Java code, which is understandable and very easier to understand. So here I will, it will be easy to understand, to reverse my application. So to summarize, I have my APK, my application. I will decompile it and depackage it to have some source codes, some resources like images, configuration files, etc. Okay, so now it's cool, but I have my root protection. So how will I bypass this protection? First step, I will take my application, because the application is on the mobile. I will run these commands. So the first one is to find the package name. Here I can list the packages which are on the mobile phone. Okay, my package name is this one. Now I will have to look for the path of the application. So with the package name, I can get the path. And finally, with ADB pool, I can take the application, take the APK, the file, on my computer. So here, I have downloaded the APK, and it is on my computer. So first step. Then I will check what is in this file. So you can see some resources. Here I see an icon with other XML files. You have small files here, okay, and manifest.xml if I want to change some configurations. So we will change 3 things. We will add a debug flag to enable logs. It is to have more information on the console, and with this, we will have more information during the run of the application. We will change the icon for visual demonstration, and of course, we will try to bypass the protection. To enable the debug, to enable the logs, I will just have to change this in the manifest file. So just change the false to true, and that's it. For the icon of the application, I can just replace this safebank icon.png, and I will change the icon of the application. But concerning the bypassing the protection, I will have to look into the code where is the protection. Before changing anything, I have to find where it is. So you can try this software, which will help you to have a diagram of your application. Which methods call which method, which classes is linked to which classes. So it will give you the architecture of your program. Okay, it's a solution, but here root protection is very classic, so there is other solution like Mara. So Mara, it is a framework, and with this framework, I can directly have detection of this protection. And here, it gives me 2 classes, main activity and utils. And here, I can see that there is something interesting here. Is device rooted, and there is some checks in the utils class. So it's enable me to find where is the protection. Okay, so now I will check in the class. What is the method is device rooted? Okay, fine. It's test it, and finally it returns a Boolean. So I understand that if I return false, it's okay. I will not change the Java file, but here I have the small e, so I just have to return here another value. So that's it. I will create another constant with 0 and return it. I do anything else. The code, the other commands will stay as it is, but here it will always return false. Okay, now I have to install my application in the phone. So I will use APK tool, build with my package, etc. I will sign the application with my own key. And finally, with ADB install, I install the application, the modified application, in the phone. And so what's happened? Here, the icon has changed, and there is no more protection. The application runs on the rooted phone. So 1 point for me. Just something it is important to understand. Here, I sign the application with my own key. So it means that I cannot put the application, the modified application, and replace it in Android Store or Apple Store. It is not possible because it is now my application signed with my own key. But what I can do is to say, okay, it's a Spotify application which is free, and you can download it on another alternative store. But in fact, it is a modified Spotify, and I put some malicious code inside.
So now that I will make a new version of my application because I really need to prevent access to my code. So for that, the authentication is the solution because it really prevents to access code, access all the business flow, all the logic that we just saw, all security checks like authentication, cryptography, and also, of course, root and jailbreak detection. Also, all sensitive information like key, key certificates. So, and how does obfuscation do all the things? So the first one, first example, is to rename classes and methods. So it remains of making classes and methods not understandable by their names. Also, the string that you can have hard-coded in your code, they are ciphered, so they can be retrieved with uncipher, but they won't be understandable easily. And also, obfuscation modify the control flow, the business flow, so it makes it harder to understand. There are some tools. The most known is DexGuard. And yeah, we go see an example. So here we saw the code in clear with all classes. And we can see obfuscation just like a loop. The more you run the loop, the more you will have complexity in your code. And the more and more you have complexity, but the more and more you will have a lower application, maybe. And so you have to make a compromise between having a very hard an application to understand by attackers and having a performant application when you run it on all your user smartphones.
Okay, so we saw how to analyze the code. Now we will see how to analyze the memory. Memory is there is different type of memory. We saw the source code. Maybe you can have some information in the source code. You have different other type. And here we will see what is in the log file and what can be found in private application folder. Because here, okay, I can run my application, but there is a login page and I don't have the PIN. So I have to try to bypass this login. In the log, what can be seen here, we see that I test the application on my mobile. I put 1234 to test. And in the log, I see that 1234 is here, and it is converted into a string, a long string, a complex string here. So the pin is hashed into this string. Okay, and then what is done? There is the call of get shared pref, and this shared pref, this is the private application folder. Okay, there is something interesting in the shared pref. So no problem, I can go in the phone and check what is in the shared pref of my application. There is a file, mainactivity.xml, and what contains this XML? It contains my pin. In fact, not my pin, but the pin, the right pin, which is protected here. And okay, I will not be able to understand the pin because it is not the pin directly, but only the hash of it. So it is well protected. It's not the good, it's not work for this one. But I will try another method, and this time I will use dynamic analysis. Dynamic analysis, what it means? I will do instrumentation during the run of my application. To do this, I will use Frida. Frida is a dynamic instrumentation toolkit, and it's very simple. The principle is very simple, but it's very powerful. It can analyze and modify running processes, and it can inject your code in the application, and even in libraries, in Android libraries or iOS libraries. How it works? In fact, without Frida, you have your application here, and at the beginning of the application, it will go to the memory. It will go to the library. For example, if you have the method open in your application, the application will load this library and put the open function in memory. During the application is running, the application needs the open method, so it will take this method in the memory and run it. This is the classical, it works like this without Frida. But with Frida, the first step is modified. During the loading of the libraries, Frida will replace the open method with an open method but modified by Frida. So in the memory, you have your open method, which has been modified, and during the run of the application, it will use the wrong method. How it works, what is interesting also is that Frida is scriptable, so you can automatize this modification. You can use it on Windows, on iOS, on Linux, etc., not only on Android. And you see that I doesn't need to access to the source code. If I know that this method is called, I can modify the method. So it is used for analyze application, for pen testing, also to intercept network traffic, etc. And of course, to bypass protection mechanism. So this is my script, my FRIDA script, and here I know that the pin has to be compared to a string. So what is the method used for this? It is the method equals from the string class. So I will overload this method equals, and to start, I will just add a log in the equals method. I run this command to be root, to run FRIDA, and to run my application with FRIDA. What can I see? Now, each time the equals method is called, I have a log, and here I can see a lot of log of comparison between files. In fact, remember at the beginning, there is a root protection, and this is how the root protection works. It will test specific files, these files, and if the file is present on the phone, it will trigger the protection, and it will say, okay, there is a specific file for rooted device, so the mobile is probably rooted. But that's not the point here. Here, what is the interesting thing is here you can see that there is a comparison between my 1, 2, 3, 4 pin and the good one, which starts with 5, 3, etc. So you can see that here I have the comparison between the two values. So what I will do, in fact, I will replace my log by this line of code. And what I will do here, in fact, I will say, each time you use the equals method, if one parameter is 0, 3, and so on, return true directly. So if I put 1, 2, 3, 4 in the pin here, I will have 0, 3, AC, etc. in my pin, and the equals method returns true. And that's it. I directly change the behavior of the application, and I can log in the bank application. And equally, I take another point.
But here, it is just for an example. Of course, here, as in my bank application, I get to learn that all this kind of authentication must be done on the server side and not on the application. But yeah, here it was for the example.
Yes, indeed, the comparison, remember that you are in the white box model, so each time you do something in the application, the attacker can see it and can modify it, so do sensitive things on the server. Just to have another example of what can be done with dynamic analysis and the memory. Here, we will see how it works in the temporary storage. Remember, at the beginning, we have modified the application. We can have add malicious code in it and distribute it on an alternative store. Here, you have to imagine that we are on the victim phones this time. It's not my phone, it's the victim's one. And the application is not the original, it is a malicious application. And in the application, the victim will enter his PIN, but the malicious code will download everything in the memory. So to do this, you have to know the process of the application. So with the package name, I get the process, the name of the process, the number of the process. And with the number of the process, I can dump it into a file on the mobile and copy every memory for this application into this file. And once it's done, I can download this file either on my computer or thanks to the network, I can send it to a server to analyze it. So here, I get this file with the memory inside. And I can analyze it with Memory Analyzer. It's tools used to find memory leaks or reduce memory consumption, but it can also it will analyze the memory. So if you have the file, you can go in the file and find what is interesting here. The do-login method here, you have the method do-login. And in this method, you have an attribute which is called password. And here, in the memory, of course, there is the value of the password. So this method is more complex to do because you have to modify the application to find a way to install this application on the victim phones, etc. But it's possible to see the password here because, of course, once the victim will have to put his password and it will be somewhere in the memory at this time. So it's just 1 point for me to be sure.
So here we had an overview of what can be done on applications, some hacking things. You must know the OWASP organization we mostly know it for the web vulnerabilities, but they also published their mobile security projects. So here are the top 10 of vulnerabilities on the mobiles. There are also the testing guides, which is more complex and more complete about all vulnerabilities. And here we just put the top 10, but we saw some of them already today with the improper platform usage, so using a rooted device, the insecure data storage with the RAM, the application files. Also insecure authentication, must be done on the server side, and also code tampering and reverse engineering. So you can find a lot of more information with the OWASP mobile security project. So to conclude, you saw today a lot of tools that are existing for every different purposes. All these tools are open source, so you can all test your application. And I said your application because it's forbidden to hack real applications and other applications that you don't possess. So don't hesitate to hack yourself when you develop your applications. Because you have to be a good hacker to be a better developer and a better defender of your applications. Thank you all. I think we're good. Do you have any questions? I think there's time for questions.
Okay, thank you very much. And now if you have some questions.
So, first of all, thank you for the talk because it was very interesting. But I wanted to ask, do you know if there are, I mean, I'm sure there are, but is there somewhere we can find like similar tools to do this for iOS apps? Because Android is very open and of course, it's very easy to find these things, but I guess there are similar things for iOS too.
Yes, we are not specialists on iOS, but the principles are likely the same, and there is some protection for iOS, like alternative store. It's very difficult to install an application from. It's not possible, I think, to install an application or to. It's more difficult. Okay.
It's more difficult, but
Okay.
it's possible. Yes.
Okay.
Okay.
So something like this, there is difference, but the principle are globally the same. Yes.
Okay, thank you.
Thank you for the talk. Julien, you make it seem very, very easy to hack into all those things. Is it really that easy in real life?
Is it that easy?
In fact, doing this, it's really like yes, it's really like easy. Concerning obfuscation, in fact, the obfuscation protection is by default. In fact, now, so a few years ago, I would say yes, it was really easy. Now there is some protection, so it's complicated to take an application and directly understand it.
Plus,
But
IDE, there are some application for developers. Their workspace is that build the application. They directly obfuscate at a little level, but some building tools do the thing, do the little obfuscation all the time. So yeah, that's why today there is a minimum of security for every application. More and more there.
yes, and but if you are on your own device, it's really easy to take an application and hack it. What is difficult is to insert malicious code in the victim phone. So this is the difference between taking an application, reverse it, hack it, but now you have hacked yourself, but not the victim or something like that. But it's very important to understand that every code that you put in the application is visible to the attacker. Every secret that is in memory is visible to the attacker. You have some tools in Android or iOS like keychain, key tools, keychain, key store, yes, to protect a secret, and it's important to use it.
Any more questions? Okay, so there is. No. Okay, so thank you very much.
Thank you.